This one is an extremely beautiful question. It is not a concept-based question, very simply based on very basic observation of numbers and particularly squares. Okay. It says Golu and Chotu, who are two brothers, share a herd of X cows. They take the cows to the market and sell each cow for rupees X. So total money collected would be X into X. This is the total amount that they will collect because the number of cows is X and the price of cows is also X. So total amount will be X into X, which is X square. So X square is the total amount. Now all this money is in either 10 rupee notes or 1 rupee notes. So suppose if I assume that there are A notes of 10 rupees and B notes of 1 rupee. So it is 10A plus B. Wow. Such a nice situation. 10A plus B. One at a time, they take out 10 rupee notes. The brother who draws first also draws the last. So A has to be odd number. Fantastic. A has to be odd number. A has to be odd number. Note this very carefully. A has to be odd number. Okay. The brother who draws first number also draws the last number, right? Just for example, first one gets, then the second one gets, and then the first one gets again. So if I end here, total number of notes will be 3. First one gets 1 note, second one gets 1 note, first one gets 1 note, second one gets 1 note, and the first one gets 1 note. So if I end here, 3 and 2, total there will be 5 notes. So that's what I mean by saying A has to be odd number, right? So the distribution of 10 rupee note has to be in such a manner that the first 10 rupee note goes to the first person and the last 10 rupee note also goes to the first person. So that means the number of 10 rupee notes is odd. So A is an odd number. One at a time and 10 notes. The brother who does, okay. The second brother complains about it. So obviously because he is getting 10 rupee less. Why 10 rupee less? Because obviously if the number is odd, say just for example, if I randomly take A equal to 7. So the first brother will get 4 notes of 10 rupees. So amount will be 40 rupees. And second brother will get 3 into 10 rupees. That is 30 rupees. So 40 and 30. Right? This is the situation. The interesting part is, so the first brother offers him all the rupee 1 notes without taking any. The second brother still received a total less than the first. Interesting part is, even if I give all 1 rupee notes, this value still has to be less than this. Okay, sorry, I marked it wrong. This value still has to be, this is just one case. This is still, even if I gave all 1 rupee notes to this person, this is still less. So what does that mean? The number of 1 rupee notes has to be less than 10. Because in any case, when you distribute, it will always be like this. The difference of 10 rupees. When you distribute 10 rupee notes, the difference will always be 10 rupees. I'll take another example. If A is 9, see what happens. The first brother will get 5 notes of 10 rupees. Second brother will get 4 notes of 10 rupees. So 50 and 40. If A is, let's say, for example, 15, okay, then the first brother will get 8, so 80 rupees, and the second brother will get 7, so 70 rupees. So again, the difference is 10. So what is happening? The difference of amount is going to be 10 rupee after the distribution of 10 rupee notes. After that, even if I give all 1 rupee note to the second person, it is still less than the next one. So what does that mean? The number of 1 rupee notes has to be less than 10. So what do we know? We know that A has to be odd number and the value of B has to be less than 10. So B is a single digit number, right? Then what does it say? Without any, the second brother still received total less than the first brother. So he asked the first brother to write him a check to balance things out so that the total amount becomes equal. After distribution, the amount becomes equal. Now, there's another interesting thing. See, such a beautiful thing to analyze. If the amount has to be divided into 2 equal parts, that means this whole thing has to be an even number. Now here, 10A is already even, so B has to be even number. Wow. See, it should be divisible into 2 equal parts. Then only the things will balance out. And here it is, question is given that by writing a check, the amounts will balance. That means the number has to be an even number so that it can be divided into 2 equal parts. So what should be the amount to be paid by check? So basically what we want, how much should the first brother give to the second brother so that the amounts become equal? Okay. Fine. So very nice situation. I'll just remove those things which I had written to give you an understanding as simple examples. Okay, now how do we do this question? So what all do we know? We know that this 10a plus b is a perfect square. We know that b is an even number. So the last digit of this number is even. 10a plus b, whatever is the value of a, b is always going to be the last digit number, it is less than 10. Okay, so and that is even, right? So x square is even. So I'll just write the possible values of b. Possible values of b will be, b cannot be 0. B cannot be 0. B cannot be 0, right? Because by giving some amount, the amount is becoming equal, right? So b cannot be 0, 2, 4, 6, 8. In fact, even if it is 0, nothing to worry about. Even if it is 0, nothing to worry about. Is it given somewhere? Okay, the second one, take out 10 rupee note. The brother who draws, all the money is in either 10 rupee notes or 1 rupee. Okay, so I think it is not given. Cheque, no problem. No problem. Not given, so I can take 0 also. So this brings us to another case. So as of now, we will assume that there is at least one note. So I'll put that condition, at least one note of each denomination. Okay. At least one note of each denomination, because from the second one it doesn't actually clearly says, some people will take this, that, even after receiving all 1 rupee notes, now if the number of 1 rupee notes is 0, then what? So it is still possible. So as of now, I'll discard 0 with a condition given that it can be note of each denomination. So last digit even, so b can be 2, 4, 6, 8. The interesting part is, you have to understand that b is b is what? B is the unit digit or last digit, okay, of a square, right? Now in a square, what are the possible last digits? In a square, last digits, the not possible are 2, 3, 7, 8. Do you remember that? 2, 3, 7, 8 are not possible last digits in a square. So in a square, the last digits possibilities are 0, 1, 2, 3 is not possible, 4, 5, 6, 7 is not possible, 8 is not possible, 9. So these are the possible values. Out of these, the odd ones are already gone for this particular question. The even ones are 0, 4 and 6. 0, I have already given a condition that we have to have at least one number. So I have 4 or 6. So B can be in this case, now what do I know? Either 4 or 6. This is another problem. Now come to A. Don't forget, A is an odd number. So whatever you do, if you take the value of this, try and understand random, just to explain, if I take A equal to 7, this is going to be 7b. It will look something like this. If I take A equal to 15, the number will look like 15b, right? If I take A equal to 27, it will look like 27b, and so on. You see, so what is happening? If in the end, whatever is b, the tens digit is an odd number. And if you check the squares, 4 square is 16, 6 square is 36, 14 square is 96, 16 square is 56. I'm just writing the last two digits of different squares. Okay. Whatever you do, the suitability for an odd number before this, it is, fantastic. So the only possibility for B is 6. Okay. Because if I have 4 in the end, then before 4, what should be the number? It should be 04 or 44, 2 square, 12 square, 8 square is 64. So 2 square is 04, 8 square is 64, 12 square, last two digits 44. So if I have 4 in the end, I should have even number before that. So 4 is also ruled out for B. Wow. So the only possibility for B is 6. Fantastic. So now what do we know? Now we know that A is an odd number and B is clearly 6. There is no other possibility. There is no other possibility. That's it. It is done. So we already had a situation where the difference between the two amounts that we were distributing with, the difference was 10. This guy gets 6 rupees. Still there will be a difference of 4. Difference of 4. So how much amount should be given in the check? To equate, we should give 2 rupees. Right? So till now, okay, I'll explain this part again, don't worry. We have identified B equal to 6 and it is a unit digit of a square. In a square, if I have 6 in the end, before 6 it will always be an odd number. In a square, if I have 4 in the end, I'll always have an even number. But I cannot have even number according to this situation. So the only possibility of value of B is 6. So I'll just remove all this because we need space. So total amount x square, that is equal to 10a plus 6 and a is odd. So when you distribute, let's take an example. Let's take a equal to 7. Just for example, but a equal to 7 will not satisfy. Okay, so think of something else. Let's take a equal to, because we need to have a perfect square, right? Check which one will satisfy. So if I take a equal to 1, yes, this x square will be equal to 10 plus 6, 16. 3 will not satisfy. Oh, 3 will satisfy. Fantastic. A equal to 3. 3 will also satisfy 36. If I take a equal to 5, okay, 56 will not be possible. Right? If I take a equal to 7 will not satisfy. If I take a equal to 9, 96 is not a perfect square. Then the next number that is going to satisfy is 16, 25. If I take a equal to 25, check that carefully. Yep. So basically this is 4 square, this is 6 square, this is 6 square. So the next number that will satisfy is 14 and 16, right? So 14 square, so for that take a equal to 19, the number x square will become 196 and that is 14 square. And take a equal to 25, for that x square will be equal to 256, which is 16 square. Right? So these are possible, but in any case, we don't need to go that far. Take any one example. Let's take this one, 36. So if this is 36, what does that mean? 30 plus 6. That means 3 notes of 10 rupee and 6 notes of 1 rupee. How do you distribute these 3 notes? 20 to the first child and 10 to the last child, the second person. Even if I give this 6 to this person is still having only 16 rupees. This person is still having 20 rupees. So the difference of 4. To cover up the difference, this person should give 2 rupees. So that this becomes 18, this becomes 18 and the amounts become equal. Let's take another one just to explain. If I take 256. So 256 is what? It is 250 plus 6, that is 25 notes of 10 rupees and 6 notes of 1 rupee. Now how do you distribute 25? 250, it is 130 and 120. Okay, even if I give the 6 rupees, it becomes 126. So 130, 126, the difference is still 4. So in any of these cases, the difference is going to be 4. Now to make them equal, this person needs to give only 2 rupees to this person. So that this becomes 128, this becomes 128. So the transaction in the end that is required to be done is only rupees 2. Rupees 2 should be given. So check the options. Option C is the correct answer. So this was a very interesting question. A lot of awareness of squares would have helped to do it very, very fast. Okay.